So a 9-volt battery is connected to a 100 ohm resistor, and a voltmeter shows the potential difference across the battery to be 6.7 volts. So what's the internal resistance of just the battery? Well, in order to solve this, we're going to need two identities. The first one is the potential difference across the battery, which is delta V, which is the change in potential, is equal to the electromotive force minus the conventional current times the resistance, or the internal resistance. So the second one is the current through the circuit, which is just conventional current is equal to the electromotive force over the resistance plus the internal resistance. So what we're going to do is we're just going to plug this into here, giving us this. And pretty much that's the whole problem. The rest of it is just rearranging it for the internal resistance and then just plugging in some given values. So I guess I'll do that. So I even wrote it down, just rearrange to solve for R internal. So first things first, factor out the EMF. Both these terms have EMF in them. I just rearrange, distribute this R internal. Divide by the EMF, then move this -1. Divide by a negative, and this is what you'll get. Now we can start solving after we get to this point. So we're now solving for the actual internal resistance. So just remember what our given values were. We've got 6.7 volts for our change in potential for the battery. I wrote 9 because I mixed up the EMF and then the other one. It's like 2 in the morning. Sorry. And the resistance is 100 ohms. So now just plugging in these values into the equation. So it's 100 ohms plus the R, the internal resistance. I'll always keep saying that wrong. And then 1 minus the change in potential over the EMF. So just punch that into our calculator, just distribute this over, and this is what we've got. Subtract this over to here, and then just factor out this internal resistance variable that we'll be solving for anyway. Then we've got this, just divide by this, and then you end up with 34.30 ohms for the internal resistance.